My involvement with Intel is on two ways. The first way was in our supercomputer work. Intel, after we developed the finite element machine at Langley, and then Intel decided there was a market there. So they developed something called a hypercube. And then they extended that hypercube into a Delta machine, which they put at Caltech, which I mentioned about that display we had to get out to Caltech. But anyway, we worked on the Delta. We were some of the first ones, and that was parallel computing, big time. So out of that work, we showed that you could substantially reduce the analysis time over anything you could do on other supercomputers. So it really changed the way supercomputers were from the conventional Cray vector architectures to the parallel architectures, and our algorithms demonstrated that. So out of that, they asked me to join the Intel Supercomputer Users Group, because the Caltech Delta machine was a Intel supercomputer. So we were using it, and they wanted us to show our results. So they had a meeting that I participated with out at in Oregon, and I got to see a lot of the movers and shakers in the supercomputer industry there. So I continued on that supercomputer board, and there were meetings held every year, probably for about 10 years, and they gave me a plaque after my service there. So that was one of my involvements. And in fact, through that involvement, people at Oak Ridge, I got introduced to a bunch of those people from Oak Ridge, where I'm heading now, from those supercomputer days. The other Intel connection, which really had nothing to do with the Intel Supercomputer Users Group, they called ISUG, was when they came out. Remember, they had a chip, I forget which version of the chip it was, which they had a problem with the floating point architecture. And they didn't want to repeat that again, because then they had to return chips, faulty chips and things like this. So they decided next time around, when they came out with they called it a P6, and there's a thing over there about the P6, they decided, and I think it was the Pentium Pro or one of those things, but they called it a P6 internally. They decided, why don't we just have a contest and have people try to break the chip ahead of time rather than do it after. And so they opened up this, anybody in the world could apply and propose something that would tax or really work their chip to death. So I saw that, and it said that they will give you a free development system. That means you don't just get the chip, you get a whole system with all the software, oodles of disk space, and a modern computer system that has their chip inside. So I said, well, yeah, I think maybe I'll just apply for that. I didn't even check with my branch head or anything. I said, I might just do it at home. But so it turned out I applied for it, and I decided, well, I know the structural analysis and the equation solver stuff, so I'll just test it out from that regard. And those things really tax computers. So it turned out that we won. I got a call, and they said, well, we're going to place a system. Where do you want to ship it? And I had to quick decide, am I going to ship it to my home or ship it to NASA? So I went down and talked to my supervisor and said, I've got this brand new Intel system, and it's something like 9 months before the chip is actually going to be available to anybody else. And we got it ahead of time as a prototype just to check it out. And he said, do whatever you want, whether you want it at home or here. So I decided, well, if I have it here, I can have fun playing at work and finding out a lot of new things, and then I can see our software, how it performs on the next generation chips, and basically be ahead of everybody. So we got the system. It was shipped to Langley, and then I found other people at Langley wanted to access it. So I had to give a weekly report, was one of the things I had to do, and they were basically looking for bugs, and we found some bugs. But before that, other people heard that we had it. You wouldn't be amazed. You get the only thing, like we got the first prime computer, and suddenly people all over Virginia wanted to access it, and then they ended up buying them. But the same thing here. So we put it on the network so other people could access it, and CFD and so on. What we found is I ran a bunch of structural analysis programs, smaller, bigger, 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 and we got up to millions of equations. And once it reached a certain point, oh, the performance was phenomenal up to a certain point, and then it just started to really get bad. So we looked into it, and it turned out they didn't have a problem on their chip, but a companion chip was not addressing the disk space properly, and it was taking 10 times as long as it was supposed to. So we reported that and showed the data that up to a certain point it was fine, but then after that, when it started involving disk operations, this was really slow. And so they took that and they improved that companion chip, and then when they released their product, then everything worked fine. So we actually helped them in that regard in Intel. And then in the supercomputer users group, also they gave us some inside information. Every meeting they had, they talked about their products coming down the road and stuff like that. So it's been a good working relationship with Intel. They established their supercomputer division out in Oregon. A lot of their things are in California, but they've been moving up to Oregon. It's cheaper for them up there. And their supercomputer division was a big success. The reason they closed it was that the server division was even a bigger success. I think the earnings that they're making in the supercomputer division was like 5 times, and then it was like 25 times in the server division. So they said, even though we're getting a profit, we can even get a bigger profit in the server division. So I've been involved in things where I can see what's happening and why people transfer from one group to the other, and had my tentacles out in the different organizations, which helps Langley, I think, in the long run when you're making decisions what to do and what directions to take in the future. And the recent thing is the field programmable gate arrays, and those I would predict are going to be making a big impact. They're already into Cray supercomputers, into Silicon Graphics, into Nalotech. They allow you to do tremendous capability. I think at Oak Ridge they're going to they're looking in the future technology group down there, and they are very interested in that, as well as processor and memory, and there's new chips popping up that can be used in a variety of things. So the computer technology, some people, yeah, here's another concept that I've always had. There are people that are very positive, which I feel I'm very positive about things. And then there are some people that are negative. And I found, the people at the governor's school, the students over there, all positive young kids. They don't see why they can't do something. They're thinking, yeah, I think I can do it. And so what I try to do when I work with somebody is, identify the positive thinking people and work with them, and you can get so far. The negative ones are good once in a while. You want to have them in a conference to review things to see if everything's on the up and up. But if you stick with the positive people, I think you can really go very far. And that's been kind of another thing that I've noticed in my years here, that you don't just sit there and try to argue with somebody that doesn't agree with you. I mean, there's people that don't agree with me, and you can respect them for it, but you don't go and change your lifestyle because of that. If you have a great idea, you go with it, and there will always be naysayers, but I think you just go with the positive thinking people.